All right, so let me go ahead and talk through kind of the steps I would recommend you follow on these. All right, so first, what I would do is look for where the variable is located. It's in the power, so you're dealing with an exponential function. The base of your power is a positive. It's a number greater than 1. So you're looking at this growth model as your general form. Okay, so here's your growth model as the general form. All right, so now what I'm going to do is I'm going to go through and start to apply the transformations. I'm going to start with the vertical shifting. The vertical shifting takes care of these two conditions. It identifies the horizontal asymptote and it answers this question. So when we look on the outside of our function, we have this plus 3. That means that the vertical shift is up 3. So I'm going to move this 1, 2, 3. So my new asymptote is at the value y equals plus 3. So I can write that as my asymptote. It's always going to be an equation in that form, y equals whatever the vertical shift is. And next I'm going to move to my horizontal shift. My horizontal shift is, again, this critical point. It's going to tell me the x-coordinate for my critical point. So when I look inside my function, the value of x that would make this expression equal to 0 is going to be my horizontal shift. So the value of -1 would give me a 0 inside for this expression. So negative is to the left on the horizontal direction. So -1 is my horizontal shift. So this point is going to be moved to the left one. Now, in order for me to find where that point's going to actually lie, I'm just going to plug that into my function. So when I plug in a -1 here, I get -1 plus 1 is 0. 4 to the 0 power has a value of 1. Times this -2 multiplier is -2, plus 3 gives me an overall value of 1. So this point that I get is -1, 1. So I know that this point is going to be in my function. Okay, so right now, as I look at this, I have my function shifted up, over. Okay, so I'm kind of looking at it as being right now somewhere along up here. But I also have this negative out front, so that tells me that there is going to be reflection. It's vertical reflection across the x-axis. Okay, and across the x-axis, now we actually have that horizontal line, which is the horizontal asymptote. So it's going to be reflected across here. So the graph is actually going to look like this. It's going to approach the asymptote to the left now because, again, it got reflected across this blue line, dashed line. This point, when it's reflected, is going to pass through the value that we know is our critical point. And if we continue, the trend of that line extends down. Okay, and so here's our graph. Is there any shrinking or stretching occurring based on this a value, this multiplier? Again, the negative is the reflection. Is the absolute value of this greater than 1? Yes, therefore it's going to have a vertical stretch effect, which makes it steeper. And now we can find our domain range and left and right behavior. So the domain are the x values. To the left, lowest x is -infinity, highest x is +infinity, which is going to be the case for all of these exponential functions. The range does vary. So here again we start down from the bottom up on the range. Our lowest y is -infinity and extends all the way up to our highest y value of 3. It never actually reaches those, so it's parentheses on both. The left behavior is it approaches the asymptote, and our right behavior, it falls or goes down. And we've answered all the questions about these graphs.